Hey guys, in this video we are going to find a term of a sequence. We're going to find the sum of the terms of a sequence, write an expression for a sequence, and we are going to find the limit of a sequence. So first we are finding the 29th term of this sequence here in number 1. So what's happening here in number 1? It looks like it's going up by the same amount each time. So let's try subtracting second term minus the first term. We get 12, and if I'm correct that this is a common difference, then 16 minus 4 will be the same, and it is. So we have a common difference here of 12. So we're looking at an arithmetic sequence. So we want a sub 29, the 29th term. So to get that 29th term, we do term 1, negative 8, plus the common difference times n minus 1. We're looking for the 29th term, so it's 29 minus 1. Okay, so we've got the first term already, so we only need 28 more. That's why we do n minus 1 here. So we have negative 8 plus 12 times 28, and that is 328. So the 29th term has a value of 328. To get the sum of the first 29 terms, we do n divided by 2, so that's 29 over 2, times the first term plus the last term, and the last term is term number 29, and that is 328. So we have 29 over 2 times negative 8 plus 328. And that is 4,640. So the sum of the first 29 terms is 4,640. Next, we have 3, 7.2, 17.28. That does not look like it's going up the same amount each time. So let's use division and see if there's a common ratio. So we have term 2 divided by term 1. And if there is a common ratio, then term 3 divided by term 2 will be the same. And it is. So we have a common ratio here of 2.4. So to find the 29th term of a geometric sequence, we do the first term times the common ratio to the n minus 1 power. So that's 29 minus 1 power. So we have 3 times 2.4 raised to the, I need to close those parentheses, raised to the 28th power. Okay, so we get 1.32 times 10 to the 11th. So that is the value of the 29th term. For the sum of the first 29 terms, we do the first term minus the first term times the common ratio to the nth power, all over 1 minus r. So for this one, I'll put it in the calculator in one step, but I need to use parentheses around the numerator. So 3 minus 3 times 2.4 raised to the 29th power, and I'll close parentheses on that numerator, divided by the denominator, also in parentheses, 1 minus 2.4. And we get 2.28 times 10 to the 11th power. Next, we will write an expression for a sequence. So we have the same sequences here. So for the expression for this arithmetic sequence, a sub n equals the first term plus the common difference times n minus 1. And I can distribute that 12, so I get negative 8 plus 12n minus 12. So that's 12n, and then negative 8 minus 12 is negative 20. And then for this geometric sequence. A sub n equals the first term times the common ratio to the n minus 1 power. Now I can't multiply these until after I do that exponent. So exponents comes before multiplication in order of operations, and that means I cannot simplify this until I know what n is. And last, we will find the limit of this infinite sequence. So we have here the limit as the term number approaches infinity of 5n plus 3n squared all over n. I am going to split that fraction. So I have the limit as n approaches infinity of 5n over n plus 3n squared over n. So I just took that fraction and split it into the sum of two fractions. And now I can simplify them. So it's the limit as n approaches infinity of, those cancel, so 5 plus 3n. Okay, so as the term number approaches infinity, this 5 does not change. So I've got 5 plus, and then as the term number approaches infinity, so this number gets bigger and bigger, I have 3 times 1 is 3, 3 times 10 is 30, 3 times 100 is 300. So as this n gets bigger and bigger, this term gets bigger and bigger, going off toward infinity. 5 plus infinity is infinity. So the limit is infinity, which means there is no limit.